Welcome back to Fossil versus Future. I'm Daisy.
And I'm James.
And today we're going to talk about...
energy.
What about energy? Our lives are intertwined with energy. It powers our homes, our cars, and even our bodies. But what exactly is energy? Fundamentally, energy is the capacity to do work. And according to the law of conservation of energy, energy can neither be created nor destroyed. It can only change from one form to another. Energy comes in many forms. Kinetic energy, the energy of motion; potential energy, energy stored because of position; thermal energy or heat energy; electrical energy, chemical energy, nuclear energy, and more. So you can't make energy from nothing, and you can't make energy disappear. All you can do is transform it. Almost every device we use is designed to convert energy from one form to another. A simple example is a light bulb. It converts electrical energy into light, but it also produces heat, wasted energy that does not serve our main purpose. Energy may be wasted, but it's never lost. To understand energy systems, it helps to think about energy in stages. Primary energy is energy as it exists in nature. Coal before it's burned, crude oil, uranium, or sunlight. Primary energy can be renewable or non-renewable. Renewable sources like wind, solar, hydropower are naturally replenished. Non-renewable sources like coal, oil, and natural gas are not, and burning them releases greenhouse gases. When we convert primary energy into a more usable or transportable form, we get secondary energy. For example, when we burn coal in a power plant to produce electricity, electricity is a form of secondary energy. Secondary energy also includes liquid fuels, such as petrol or diesel, which are refined oil. Once secondary energy reaches the consumer, it becomes final energy. This is what a consumer buys and receives, such as electricity in a home or petrol at the fuel pump. And finally, there's useful energy, the energy that actually delivers the work we want: light from the bulb, movement from a car, and heat from a radiator. At every step of the chain, some energy is lost. In many cases, a lot of it. The energy transition is the process of shifting energy production away from sources that release greenhouse gases to those that release little or none. Today, around 3/4 of global greenhouse gas emissions come from the burning of fossil fuels for energy. So tackling climate change means moving away from fossil fuels and generating energy differently. But it also means rethinking the entire energy chain.
So we were inspired, if that's the right word, to cover this topic in another way, largely by reference to the pronouncements of the President of the United States and his energy secretary, the leader writers in many of our newspapers and opinion writers in the same papers, but also conversations that I've had, I'm sure you've had, with friends and family, where there doesn't seem to be a great deal of understanding about what energy is, or if there is a deliberate attempt to misdescribe or prioritize one form over another in a way which is really unhelpful to figuring out what we should be doing in the construction or redirection of our energy system so that we can deliver all the usable energy that we need in a way that either satisfies your desire to fix the climate change issue, or if you just want to be more efficient. Because that's one of the things that emerges if you pay attention to these different types of energy. If you really zoom in on the conversion and you pay attention to the wastes, and greenhouse gases are a waste, as you described, and you look at how quickly you can get to the energy that you need to perform the task, then you would favor alternatives to fossil fuels. I mean, however remarkable they've been in growing our economy, and, frankly, for the last few hundred years, if you include the other forms of energy that we've depended upon to grow our economies, but certainly from late 19th century onwards, there's been a staggering transformation in our material lives as a result of fossil fuels.
Incredible.
Just astonishing. And much to be celebrated in that. But now, with greater knowledge, understanding, and better awareness of how one can power a society, move the things that need to be moved, do the work that energy is supposed to do, so the shift towards electrification becomes obvious. It becomes what you should do if you just wanted efficiency, if you just wanted to get work done. That's what you would do. If at the same time you want to move away from fossil fuels because of climate change, then the more so. It is really stark once you look at the comparison between primary energy and the energy that you want to do the work, how much better electrons are.
Yeah, energy from fossil fuels, so coal, oil, gas, is usually measured as primary energy. So that's the amount of energy that's generated when they are burned in their raw form. But a large amount, as we've said, of this raw energy is wasted as heat. And a typical coal plant in the US has an efficiency of 33%. So only one third generates electricity, and the other two-thirds are wasted as heat. So you need to burn 3 units of coal to generate 1 unit of electricity. And gas is slightly better, with an efficiency of around 45%. And then, like you're saying, James, the interesting thing is in popular data sets, coal and gas are reported in their primary energy terms as the fuels going in to power the power plant. But this is not how renewables are typically measured, such as solar and wind. They tend to be recorded in terms of their electricity output. So we're not comparing
No,
apples for apples.
no.
We're comparing the amount of energy generated by fossil fuels with all their wasted heat to the amount generated by renewables without this wasted
And
heat.
of all the costs associated with that wasted heat and all the pollution associated with it too. No, this is a real problem in the way we talk about energy. And
Mhm.
this is really why we're having the conversation, because it's not widely understood. In some cases, it is deliberately obfuscated. But it drives me mad when I read opinion pieces in our papers
Yeah.
who just don't get this difference. That there are well-known, figures in our opinion making world who simply don't seem to understand these different forms of energy, and who seem not to understand that electrical energy is energy at all. I mean, in some cases, some of the stuff I read, and this is one of the reasons why renewables are cast as a sort of minor suit. The idea that, if you look at primary energy, it's all about fossils, and there's so much more of it as compared to, well, it's not a direct comparison. And every time you burn a fossil fuel to create energy, you waste. You can't do anything else but that, right? And it's gone. Once it's burned, it's gone.
Yeah.
Whereas if you install a solar panel, it performs the function of conversion for however long it exists, right? The conversion is happening so much more efficiently, and it's still there the next day when the light shines. I just don't think that's widely understood. And once you add storage so that you make the electron and you use it either directly in switching the light on,
Yeah.
or you store it in a battery and you use it later, again, that's a much, I should know with mathematical precision, maybe you do, Daisy, I don't know, how much more efficient that is. But it's obvious once you get these different types, once you really focus on the energy you need to perform the task in real life, if you really zoom in on that, electrical energy, especially if it can be stored and delivered when you need it, is much, much more efficient. And then you can ask better questions about, well, how do we produce that energy at the right scale? We've got rising demand. How do we get as much of that as possible? Then that's a sensible conversation to have, and it's not without its difficulties. But we don't often get that conversation in the way we talk about energy. And there are still large sections of our political elite, our opinion-forming writers, certainly those who see political value in arguments for fossil fuels. We very rarely get a straight conversation about the value of these different types of energy.
I think traditionally that has been something that people have stated as an example of an advantage of fossil fuels is that they are a dense
They're dense.
energy
Yeah.
source. So you don't need much of a fossil fuel to produce
Yeah.
energy, and they're transportable, and they can be used when the sun's not shining.
Of course.
But like you say, batteries are improving a lot,
And so
and
is
we have
direct
that
cable,
storage. Yeah,
DC cabling. And those are the ways we need to think about
connectivity.
it, right? So
Hmm.
moving fossil fuels around the world is unbelievably wasteful. And so much of the traffic of things, of goods, is actually fossil fuels. I mean, really, I think we might have covered this before, but it's staggering again when you look at it, how much shipping is actually fossil fuels
Yeah,
being moved around, how much rail freight in the States is fossil fuels. It's a very large percentage of all the movements around the world are of fossil fuels and by fossil fuels, both. It's like a compound.
yeah,
And that whole system could be made much more efficient at moving goods around the planet. But equally, a large solar plant in a desert area of North Africa can be connected by DC cable to a large power need in Europe, right? We know that, and we've got some examples, and we ought to have more. There was a very interesting discussion I was privy to, looking at the interconnectors between the Balkan states. They're quite significant distances, but that connection allows an efficiency between their grids and allows more renewables to be put on the grid and used at various times of day and for different types of need for work done in neighboring states across the Balkans. That's a sort of the use of direct cabling is a sort of equivalent of sea traffic in fossil fuels. And again, ask yourself, it's just much, much more efficient at moving the power to the task required. And those cables, obviously, one has to be careful now. They have to be protected. I mean, in times of conflict, they're vulnerable. So there is a serious security issue associated with the transition away from fossil fuels to electrification. I don't belittle that. That's important now. Those systems have got to be cyber secure. They've got to be secure against an enemy that might want to break the cable. But once understood, you can do something about that. And of course, we've used military force for a long time to protect our supply chains in fossil fuels. Right?
but then there can be a security argument made the other way as well. The fact that 80% of the world lives in fossil importing countries currently. And so that immediately makes those countries vulnerable to losing their fossil
Yeah.
supply if relations
Yeah. And
break down.
it's often the most costly thing on the balance sheet of a nation, right? It really, really makes a difference if you're an importer and you have little flexibility in the way in which you produce and use energy in your economy, then you're very exposed to the volatility in fossil fuel markets. And yes, they can be managed, but they're harder and harder to manage from a trade point of view, the weaker your balance sheet is. So it becomes a vicious circle for a country that is both dependent and lacks economic power. Whereas light is ubiquitous. And we haven't really even got close to building out solar where it's best. You look at the most, the regions of the world where the most solar radiation is. We've barely started. And where we've found phenomenal cost savings. I mean, I think it's worth focusing on solar in particular because at least to my mind, it looks to be the technology that has the greatest potential to meet demand, including rising demand around the world. There's just still huge opportunity to build out solar at scale, as well as in small packages on rooftops in rural villages or mini grids in places where the grid does not extend. So its capacity to deliver usable energy, to get work done that needs to be done in a society, barely started, and the innovation is not going to stop. The whether it's panels getting more efficient or new materials, supply chains becoming more sophisticated, or the connection with batteries
Mhm.
improving, or the experience of joining up generation batteries and use through vehicles. All of those things are going to improve. There'll still be high demand for the materials that go into them, the minerals, of course, and some have gone up in price a lot in recent times. Silver would be a good example. But, you know, that's a challenge for business and enterprise and investment to fix, but the potential is just huge.
Why do you say that solar rather than wind? Just because it's
Mm.
easier to deploy?
Yeah, interesting. I do favour if I'm going to.
Mm,
I don't have to choose,
yeah.
um, but I think of all the technologies that we know about. I mean, who knows? Nuclear fusion comes along in X years' time, then hallelujah. I mean, I don't want to rule out other technologies that could have the same potency, if you like, in the energy transition. But I would prefer to focus on what we have and what we can do more of and make better. And solar, to me, stands out now. I know I've had many years making this case and doing something about it, from being a founder director in Solar Century in this country to Ignite now and Orbital and these other enterprises that are building out solar in the most of the world, is the phrase I like to use now. So I'm already committed. I'm already involved. I'm supporting the idea with doing it. But I'm happy to take on anyone on the theme, because I just think we've only just begun, and the energy conversion is impressive. We're not short of land areas to generate power, and certainly not in that belt of high radiation around the world. Some of the biggest solar parks that have been created to date are in that part of the world, and we've seen huge, huge developments in Rajasthan and now in the Emirates and Morocco, and plenty more places to go to build out at scale. But it's just a phenomenally straightforward idea to convert photons into electrons. I just think there's loads more to do. There'll be more innovation, more ways of doing it. I mean, I remember early on, a long time ago now, that sort of magic of being able to create a roof tile that looked like a terracotta roof tile, but converted sunlight into energy. But it's just brilliant. And then, of course, there are lots of different versions. And in some cases, we've got superior technologies that have not been picked up because they couldn't compete on cost. I mean, I remember vividly the experience of when in Climate Change Capital days, when we invested in a German thin film solar business. And at that stage, it was state of the art. And we were very proud that we had led that deal, and Intel had followed us in. And we thought,
Oh,
that's
wow.
pretty cool. And but we took hardly any time at all before much cheaper silicon-based panels from China just destroyed that business. You couldn't compete on cost. But the innovation is still there. There's still other ways in which solar power can be developed. There are higher efficiencies coming through. There are ways to deploy solar PV on curved surfaces, and there's just loads more to come. The technology itself has got, I think, the most promise of all of them out there to be the one that wins the energy conversion battle.
Apparently, 92% of countries have renewable potential 10 times their demand.
That's a good
So
number.
a lot of the numbers I'm saying are thanks to Kingsmill Bond and Ember, by the
Is
way.
that
We have
right?
to
We'll
have
definitely
to
give them
thank
a
them for,
proper
yeah,
credit, because, yeah, that report,
the Electrotech
the
Revolution
Electrotech Revolution
report
report, is
is
awesome.
fantastic.
Yeah.
Yeah.
Again, I think a lot of people just don't know that. And they can't quite picture it. They don't think it's quite real. They associate these arguments with an environmental community that they don't associate with big business or big money. I think people still don't get how significant these technologies are now, let alone what they're going to be. and don't seem to know how far big economies have gone already down this route. China being the biggest example, but India, look what's happening in India.
The rate, yeah.
India's unbelievable. The shift towards the electrostate is underway. Now, India is a decade behind, maybe. I mean, its economic growth is behind. Not in the rate. The rate is high right now. But if you look at the kind of per capita income or some other indicator of development, India's catching up.
Yeah,
China.
ahead of where China was at that same point of development.
That's a key thing.
Yeah,
that's a key thing to bear in mind. And I'm really, and they are a coal state, maybe even in some senses more. They have more. Like China, they're big oil importers. It's a very expensive item on the national balance sheet. So they have an economic incentive to get off imported oil for sure, and have done for years. But they're also a coal producer and a coal importer, and a lot of powerful vested interests in the coal industry. So it means a lot to see a country like India that has scale moving towards the electrostate vision and generating a lot more renewable power and a lot more usage. I mean, in the sense that rising demand is being met increasingly by renewables, and sectors of the economy, like transportation, maybe particularly transportation, are moving over to electric vehicles.
I think we've mentioned this on previous episodes as well, but the fact that solar and wind are meeting our growth and demand for electricity now. So that as our demand for electricity goes up, that increase in demand is being accounted for by
and we've properly credited Michael Liebreich for his great insight in his climate change reset work last year. You only do that, fantastic. Meet new demand, fantastic. Do 3% more a year, and you win in time. And it's a really important point that he makes in that. I mean, again, great recommendation to go and see that work in Bloomberg piece or his podcast. He makes a really good point, which is that, in a sense, that's all you need to do to squeeze out fossil fuels of the energy system in time. And this is a key thing, because a lot of people don't believe this, that, 3% a year, it's too late, we'll be doomed. No, what he's telling you, and I'm really impressed by this argument, what he's telling you is that if you just push on determinedly, installing more and more electrical energy, finding real focus in the delivery of the energy for a task in hand, let go of the primary energy obsession and focus on usable and work done. The more you build out renewables and the more you deliver electrical energy for those tasks, little by little by little, get there. 3% more a year, you get there. You get there, it's not perfect. It might not be 1.5 degrees, but it might be below 2. And right now, that's a good outcome. And I think we'll do better than 3% a year. I really do. We talked about this before, and I've thought about it a lot just to be sure that I'm not over-enthusing about this, because that could easily be the case. Once the system has been altered to favor the new technologies, I just think it accelerates. It just goes away from the fossil fuel base, and it won't be affected by pronouncements in the White House or Chris Wright, or Chris Wrong, as Michael and Lord Brown called him the other day. It won't make any difference. They won't get it. They will get in the way. They will advantage their supporters. People make a lot of money for a while, but they won't change the fundamentals. And it's very important, actually, for us with the work we do, but also the people who we work with, and hopefully the people who listen to this, to just get a grip on what's real. And sometimes one laughs uncomfortably at some of Trump's pronouncements. It's sometimes hard to know how to orient yourself. When he makes a statement like the Chinese don't use wind, they sell it to everybody else, but they don't use it themselves. When you know that it's the largest
40% of global wind generation
in the world by far, right? And obviously, I've got my own experience. We in Climate Change Capital Days, we this is years ago, invested in huge wind farms in Mongo. I mean, they have it's just so. What do you do with? And the answer is, you get a grip on what's real. You actually know things, and then you can handle stuff like that. The fact that there is going to be a battle between fossil fuels, and that's not new, right? And the fact that people are going to get a lift who are in fossil fuels in the States right now, I think you just ride with it, you accept it. If it drives down the price of gas, that might be quite useful for a while. Quite happy to use that in conjunction with renewables. Just if you just push and the rise of renewables is inexorable, and you start adding these technologies and you build a system around them, then you win. And then you have an energy system that is mostly electrical and more efficient.
Yeah, it's interesting because just in the last few years, this doesn't need to be about climate anymore. We really have the data now to show that this is just a better way of doing things. And I find that really quite exciting. I think go and look at the Ember report because it really does make you feel optimistic
It's
about what's going
reassuring,
on.
and one of the things we've wanted to do with this podcast, this conversation between generations, is we wanted a younger generation to feel like there was something to be optimistic about whilst taking the problem seriously, whilst knowing that their futures are affected by decisions made that they don't have power to implement right now, apart from the fact if they're old enough to vote, they do, or push through some other organization that they're a part of. So I don't mean they've got no power, they have got power, but we didn't want them to go from anger to despair. We also didn't want them to look away from the problem or pretend that the solutions were easy, or to have caricature enemies, to think harder about how you win, with whose power, what compromises are okay to make and what are not. And the energy discussion is, of course, utterly central, and we all participate in it. Maybe if you're very young, you're not doing a hell of a lot to use the energy system, but you're still doing some, all right?
Mm-hmm.
Everybody is every day they plug their stuff in, But if you had some vision as a 16-year-old or a 26-year-old that actually there's a system being built and we are getting there. And yes, there's a contest, and sometimes political power and economic power is against us, but the fundamentals are in our favor. The hard stuff is actually in our favor. The physics and the chemistry and the mathematics.
Yeah.
And the real world stuff is actually...
And the economics as well.
And the economics as well. Yeah.
I think, when we think about this energy system approach, it's the generation, the production, it's the connectivity. How are these things connected and stored? And then there is the demand piece. And I think that's the obvious place where, yes, maybe younger generations don't have the power, but we are consumers of energy. And I think one piece of feedback we've had from this podcast actually is that people want to do something.
Yeah.
And yes, we can vote, but there are also things you can do as a consumer of energy to change the way that you use energy. You can, perhaps you're not going to build a solar panel on your roof. Maybe you could, but if not, you can...
might persuade someone else to do it.
Yeah, you might persuade someone else to do it. But even just switching to a green supplier like Octopus, for example, can make a difference. Or adjusting your consumption of energy. There are many steps that you can make at home to use less energy, whether that be heating or...
all those
like
things.
You say, plugging in your phone. Don't leave it plugged in for 8 hours. Leave it plugged in for 1. These small
many
adjustments.
decisions like that.
Mm-hmm.
But maybe the biggest one is simply understanding these issues that you've set out and thinking about energy in a way that is modern and not inherited from the past, right?
Yeah.
Having a conversation with your parents or your teachers or whomever may think that somehow or other energy is fossil fuels, because that's what they know and what it has been. But in a sense, probably just visualizing what energy is and then finding out about how it's evolving ought to be encouraging. But the point you make about demand is crucial. And that's another reason why focusing exclusively on primary is ridiculous. I think the excuse or justification for that is to show off what you've got as a nation or a company. It's like, look at what I've acquired, aren't I rich and powerful?
Mm-hmm.
And that is promoted in order to display wealth and power. I have got in my reserves this amount. Well, we're going to find out how irrelevant that is when demand shifts. Right? I mean, that's the key. If the demand side of the equation changes, and at the moment it's masked because demand has been increasing for power, because we've got all these gadgets and now AI we've talked about, and demand has been increasing significantly, then the assumption is in the minds of those who produce, well, just keep going. But it won't. Demand for power will keep going. Demand for usable power until some great efficiencies are arrived at, or indeed, we had this episode on demographics that John Elkington nudged us to do. My word, was he onto something? That is a powerful force. There's some big numbers in those demographic discussions which will probably alter our perception of energy demand.
Definitely.
Right? Not inexorable rises because more and more and more people. When China's population starts to decline, and we've noted already that is happening in many of the Western economies and the highly developed Eastern economies too, like Japan and Korea. So again, the assumption is there'll be more and more and more and more demand because there are more and more and more people. Well, there will be in some parts of the world, but not in others. And so looking a century ahead,
Interesting.
There may well be a very different shape to the demographics in the world. So a lot of these assumptions about where fossil fuels will feature in the decades ahead are challengeable. Well, the most direct challenge is the fact that the work done can be done better and more efficiently by electrons.
I guess a what about that you might have in return for this argument, or get in return for this, is that some industries aren't quite ready for the electrotech revolution. I guess aviation, that it's maybe bubbling,
at the
beginning
edges
to happen, but we're not quite ready for electric planes yet.
No, we are ready for some forms that can be seen in flight now, but large aircraft carrying lots of people long distances, no.
Yeah.
Molecules.
Shipping, I guess, is another.
For now, the same story. Large, long distances, no. Ferries on a relatively short run, yes, already exist, already working. Smaller boats, pleasure boats. I was in Venice earlier this year. I mean, really, they all ought to be electric. I mean, it would be much better for their tourism industry if they're quieter and they're more efficient, and they generally get moored up somewhere that you could power. So I could see a lot of marine transport moving across to electric, but not there are other forms that look interesting, sort of hybrids that where there is some battery power or sail power. I've seen some rather wonderful designs of large vessels, container vessels with sails.
Wow.
And they carry quite a heavy load. They take a lot of the work out of the burning of fossil fuels. So the combination seems to be attractive. But the fleets, they're hard, they're expensive it's very expensive to change your fleet. And so you tend to run those vessels till they're, really worn out.
And maybe we'll need them less anyway if we have to ship less fossil fuels
We will.
around
Isn't
the
that it?
world.
That's an example.
Yeah.
We absolutely will. Yeah. We'll still ship other things, of course, but just the sheer numbers of vessels that are dedicated. And, we may, partly because we don't adequately price carbon, we will in due course in many places and in many ways, including in shipping, despite what the Trump administration has done to that part of the IMO agreement. That having an LNG vessel at sea switch direction to find better prices at a high, in another market makes perfect sense without a price for carbon, but shouldn't. Right? So there's a lot of other fixes that you could put into the system that would help the switch between molecules and electrons, which means, of course, that they'll be resisted. So you can't get past the fact that energy is politics too, and power, and they're both combined in a nation v nation way. But light is everywhere. And as long as you can get your supply, as long as you can get your supply chains stable, that's not straightforward right now because they're very heavily dominated by China. But my view is that there's a lot of knowledge now of how to make these panels, and people will catch up. And some of the other innovations will go ahead. They're just, at this stage, China has put the effort into the manufacturing of these technologies, and they're getting the rewards.
Yeah, I saw it referred to as the energy trilemma. So affordability, clean energy, and security.
Yeah.
The sort of three pillars to consider when you're building an energy system.
Yeah. And just right now, sadly, security is becoming really important. So your
Yeah.
energy system has got to be secure. But maybe as a parting shot, because this is also part of the politics and part of the way we talk about energy, we overemphasize independence, in my view. Energy security is not the same as energy independence.
Mm-hmm.
If you've got good relationships with your neighbors, right, security is more about how you move power between you,
Mm-hmm.
right? We are more secure if we've got an interconnector with Norway and with France and with that. We don't. And if we ran a cable from Morocco into Devon, which we should, X-Links it's called, that would be a good thing to do, we would be more secure. It doesn't matter that the electrons were made initially in Morocco or Norway or France. But politicians like to stress independence. They were made here, ours. And I think that's the wrong emphasis, actually. What matters is, are you secure? Have you got abundance? Have you got resilience? Have you got, these other words are important.
Yeah.
Are you resilient to threat from an opponent? Can you reliably switch the lights on and run your systems that the economy depends upon? Can you get work done efficiently and at the right price? That's much more important than did we make the electron, in our physical state.
Yeah, almost a bit of a fossil fuel mindset, I guess.
It's a fossil fuel
thinking about
mindset.
having that
It is.
physical.
It is. Some of that is fine, sure. If you've got generating your own, terrific. That's fine. But security is a more important word than independence.
Yeah, resilience, a good word in that
Resilience
context.
is very important. And abundance too, because if you want a more robust system, you want to be able to produce a lot, right? And store it if necessary, but you want to have super abundance if you can. And again, renewables promise that because there's no obvious edge to it. I mean, provided you think in an interconnected way, right? And you should be able to create phenomenal amounts of power by thinking hard about every surface that you've got, or rooftops, roadway. I mean, there's lots of opportunity to generate, and not just in, the debate is fighting over agricultural land. If you're smart, you don't need to have that sort of contest. There's plenty of other surfaces to focus on. And as I said, there are whole swathes of the planet that have just started. And when they do, they'll generate power at phenomenally low cost. That'll be a better energy system.
Thank you so much for listening to Fossil versus Future. Please subscribe to our podcast and give us a rating, and please follow us on social media. Let us know the what about questions that you want us to discuss.